Welcome, friends, to a new chapter in your educational journey. In maths classrooms around the country, the focus on perfection often overshadows our true potential. Comparing ourselves to perfect solutions can be discouraging, leaving many students feeling down and dejected. Good, or even great attempts will often be criticised for their flaws rather than being celebrated for their merits. During exam settings, this perfectionist mindset is dangerous. One mistake can feel catastrophic, triggering a downward spiral which drains your confidence and leaves you unable to perform to your full potential. But what if we could shift our perspective? We don't have to chase the elusive goal of perfection and obsess over the inevitable mistakes which drag us down. Instead, we can focus on building a solid foundation from the ground up. If we begin by targeting a 40% passing grade, we have an achievable starting point from which we can build on. So, are you ready to transform your approach to learning maths? Join me as I help you build from the base, step by confident step, towards the heights of your potential. In the 2023 Leaving Cert exams, Maths Paper 1 was divided into two sections. In Section A, you had to answer 5 out of 6 questions, worth 30 marks each. In Section B, you had to answer 3 out of 4 questions, worth 50 marks each. All in all, both sections were worth 150 marks, bringing the total to 300 marks for the paper. To achieve a passing grade of 40%, you would need to score at least 120 marks. After analysing the paper, I've pinpointed the easiest and most effective way to reach this threshold. Solving the highlighted questions would secure a passing grade. In this video, I'll guide you through the step-by-step solutions for each of these questions. This will demonstrate the minimum knowledge required to pass. If you can follow along and understand my explanations, then you can step into your own exam with confidence, knowing that you have the ability to pass the paper. Any additional knowledge you have beyond what I've covered is a bonus, allowing you to achieve even higher marks and realise your full potential. Question 1, A and B, were worth 15 and 10 marks respectively. In question 1A, the vertical bars represent the absolute value. This means that we should take the positive version of whatever number is inside. If we want the absolute value of 5 plus 3m to be 11, there's two options. Either the 5 plus 3m is equal to plus 11, or the 5 plus 3m is equal to minus 11. We can solve for m in both these cases. Let's start with 5 plus 3m is equal to plus 11. To begin, I'll subtract 5 from both sides. Then we'll simplify on the right-hand side. Next, we divide both sides by 3, and then we get our answer, m is equal to 2. We can solve 5 plus 3m equals minus 11 in a similar way. We subtract 5 from both sides, we perform the calculation on the right, and then we divide both sides by 3. This gives us m is equal to minus 16 over 3. In part B, we're given an equation and asked to express k in terms of h and j. This will involve performing algebraic manipulations to the equation until we've isolated k by itself on one side. Fractions are a bit awkward, so it's a good idea to get rid of them. I'll do this in 2 steps. First, I'll multiply both sides of the equation by j plus k. Then, I'll multiply both sides of the equation by h. Since we want to isolate k, it's a good idea to group all the k terms on one side of the equation. We can do this on the right if we subtract k from both sides. Now, we can factor out the common k on the right. As the final step, we divide both sides by h minus 1. This brings us to our final answer. K is equal to j over h minus 1. Question 2, C, I and II combine to give you 10 marks. In part CI, we're asked to consider g of x minus 2. The effect of this minus 2 is that it decreases the y value by 2 in every location. In other words, we need to shift our function downwards by 2 units. This results in the blue curve I've drawn in here. In part 2, we're asked to consider g of x plus 3. Here, a shift of plus 3 has been applied to the input value. If we were to sub in x equal to minus 4, this would come out as g of minus 4 plus 3, which is g of minus 1. This means that x equal to minus 4 on the given function corresponds to x equal to minus 1 in g of x. In other words, there's been a shift of 3 units to the left. Applying this transformation to the rest of the points gives us the blue curve that I've drawn in. Question 3C was worth 10 marks in total. To answer C part I, we must explain what log base 6 of m means. Well, log base 6 of m is the power which 6 must be raised to if you want to obtain an answer of m. Another way to think of this is that it's the value of x which satisfies the equation 6 to the x is equal to m. In other words, it's the mystery number which must be put in the power of the 6 to get out an answer of m. In the next part of the question, we're told that m is a real number which is greater than 6. We must think about log base 6 of m. Well, if you were to put a 1 in the power of a 6, you would get 6 to the 1, which is 6. We can deduce that a number less than 1 in the power will give you a value which is less than 6. A value which is greater than 1 in the power will give you a value which is greater than 6. Since we're told that m is greater than 6, the number in the power will need to be greater than 1. From here, we can conclude that log base 6 of m must be greater than 1. Question 5a was worth 15 marks. In part A, we must differentiate the function f of x is equal to 1 over 5x squared plus 7. This expression is a fraction. The quotient rule can be used to differentiate fractions. This states that u over v differentiates to v du dx minus u dv dx, all divided by v squared. Here, u refers to the number above the line. In our situation, u is equal to 1. V is the expression below the line. We'll have v equal to 5x squared plus 7. To apply the quotient rule, we'll need to differentiate both of these expressions. The constant, 1, will simply differentiate to 0, so du dx is equal to 0. To differentiate 5x squared, we use the rule of multiplying down by the power, then reducing the power by 1. So 5x squared differentiates to 10x. The plus 7 is a constant, and this will differentiate to 0. So dv dx is equal to 10x. From here, we simply have to sub in these expressions into the quotient rule. To finish, we can simplify the numerator. Anything by 0 gives you 0, and minus 1 times 10x is minus 10x. Question 6AI had 10 marks on offer. In part A, we're presented with two functions, f of x and g of x. The first task is to find two values of x for which these functions are equal. Our starting point is the equation f of x is equal to g of x. Well, f of x is x plus 4, and g of x is x squared minus 2, so let's write these in. Now, I'll group everything on the right-hand side by subtracting x and subtracting 4 from both sides. We can simplify on the right. Minus 2 minus 4 is equal to minus 6. We now have a quadratic expression on the right-hand side. This can be factorised. To do this, we need to pick a pair of numbers which multiply to minus 6 and add to minus 1. Here, minus 3 and plus 2 do the job. So our factorisation is x minus 3 times x plus 2. We know that these two factors must multiply together to give 0. The only way that this can happen is if one of the factors is 0 itself. So either x minus 3 is equal to 0, or x plus 2 is equal to 0. Both of these cases are straightforward to solve. If x minus 3 is 0, we can add 3 to both sides to get x is equal to 3. If x plus 2 was equal to 0, we can subtract 2 from both sides to get x is equal to minus 2. Question 7, A and B, were worth 5 and 10 marks respectively. In question 7, we are given a function, v of t, which specifies Fiona's speed t minutes after passing a specific point, A, on a motorway. In part A, we need to find out Fiona's speed when she passes the point A. Well, t represents the time in minutes after passing the point A. At the instant she passes A, 0 minutes will have passed. So all we need to do is sub in t equal to 0 into our function. When we do this, we get out an answer of 109 kilometers per hour. In part B, we must work out Fiona's acceleration 5 minutes after passing the point A. Acceleration can be thought of as the rate of change of your speed. Differentiating a function allows us to find the rate of change. This means that the acceleration is found by differentiating the speed function that we were given. To differentiate 2 over 3t cubed, we can use the rule for differentiating powers. Multiply down by the power and then reduce the power by 1. This gives us 2t squared. The same rule can be applied for the minus 6t squared. We multiply down by the power, then reduce the power by 1. This gives us minus 12t. A constant times t simply differentiates to the constant, so 13t will differentiate to 13. Additive constants differentiate to 0, so the plus 109 will differentiate to 0 and simply disappear. This means that the acceleration function v dashed of t is equal to 2t squared minus 12t plus 13. We want to find the acceleration 5 minutes after passing the point A. So we should sub in t equal to 5 into the acceleration function. When we perform the resulting calculation, we end up with an answer of 3 kilometers per hour per minute. Question 8a was worth 5 marks, and the 2 components of part B combined for 10 marks. In part A, we're told that Olga puts in €3,000 to a savings account. Interest is added at an annual rate of 2.4% per year, and we need to find the amount of money in the account after 5 years. To solve this question, we should open up our formula book and grab the result for compound interest. This states that f is equal to p times 1 plus I to the power of t. Here, f represents the final value, and that's what we're trying to find in this question. P represents the start amount, and here we're starting with €3,000. I is equal to the interest rate, and in our question, this is 2.4%. Written as a decimal, this is 0.024. T represents the time period, and since our money is invested for 5 years, we will have t equal to 5. Let's sub these values into our formula. We can type the right-hand side into our calculator and then round to the nearest cent. This gives us a final answer of €3,377.70. In the next part of the question, we must explain what is meant by the present value of a payment of €1,000 in 1 year's time at a particular interest rate. Well, in general, a present value represents the amount of money you would need to invest right now in the present moment to obtain the specified value in the future. So the answer here is it's the amount of money you would need to invest right now to end up with €1,000 in 1 year's time after adding any interest you might earn. In part BII, we're told that Chen invests money in a savings account with the same interest rate of 2.4% per year. We know that after 6 years, he'll end up with €4,000 in the account, and we need to figure out how much money he put in originally. To solve this, we'll turn to our compound interest formula once again. F is equal to P times 1 plus I all to the power of t. F represents the final value, and we know that Chen ends up with €4,000, so F is equal to 4,000. P represents the start amount, and this is the quantity we're trying to find. I is the interest rate, which is 2.4%. Written as a decimal, this is 0.024. T represents the time period, and since Chen's money is invested for 6 years, we'll have T equal to 6. Let's go ahead and sub these values into the formula. We want to find the value of P, but it's being multiplied by an expression. To isolate P, we should divide both sides by this expression. We can type the left-hand side into our calculator, and when we round to the nearest cent, we end up with a final answer of €3,469.45. Question 9b was worth 20 marks in total. In part B, we're looking at pairs of factors of 12. In other words, that's pairs of natural numbers, x and y, such that x multiplied by y gives you 12. The first task is to complete a table showing these pairs. The key to doing this is the following. Whatever numbers we write in, each column must multiply together to give you 12. This means that if we have a column with one number written in, the other number must be 12 divided by that number. The y value in the first column will be 12 divided by 1, which is 12. The y value in the second column will be 12 divided by 2, which is 6. The y value in the second last column will be 12 divided by 6, which is 2. And the x value in the final column will be 12 divided by 1, which is 12. There was one column in the middle which had neither box filled in. Each of the rows should contain all the factors of 12. If you look through the x row, you'll notice that 4 is the missing factor, so that's what we should write in. To find the corresponding y value, we divide 12 by 4 and get 3. In the next part of the question, we must plot these 6 points on a coordinate diagram. The first point has an x value of 1 and a y value of 12. So we go to 1 on the x-axis, 12 on the y-axis, and plot a point at their intersection. The next point has an x value of 2 and a y value of 6. The next point, 3, 4, is already plotted for us. After this, we've an x value of 4 and a y value of 3. Next is an x of 6 and a y of 2. And finally, we have an x of 12 and a y of 1. This gives us 6 points plotted on the diagram. In part 3, we're told that the relationship between x and y is that y is equal to 12 over x. We need to draw the graph of this function above. Well, we've already drawn in 6 reference points. To draw the graph, all we have to do is join these points with a nice smooth curve.